Hi, in this video, we will solve preliminary problems from Chapter 13 from this book, Engineering Mechanics Dynamics, 14th edition by Hibbeler. Chapter 13 deals with kinetics of a particle, force, and acceleration. Now, kinetic is a branch of dynamic that deals with the relationship between the change in motion of a body and the force that caused this change. So force caused the change, and the result is the mass, the object, is accelerating due to this force. The main equation of this chapter is Newton's second law, which is force equal to mass times acceleration. So here when we have an unbalanced forces acting on a particle, it causes the particle, or we can represent an object as a particle, to move, and then we can measure the acceleration in here. Okay. So here we will be solving 4 problems from page 127, preliminary problems. So problem number 1, the 10 kilogram block is subjected to the forces shown in each case. Determine its velocity when time equal 2 seconds, if velocity equal to 0 when time equals 0. So here we will write what's given to us. We are given a mass m of 10 kilogram, a time t, 2 seconds, and we have the initial condition right here, which is velocity as a function of time. So when time is 0, the initial velocity is 0. We are asked to find is what? The velocity as a function of time when the velocity is 2 seconds, or in other words, what is the final velocity? So here we have the two cases, case A and case B. And both of them have the same block of mass, 10 kilogram, 10 kilogram. And this 500 and this 300 are external forces or unbalanced external forces acting on the block, causing the block to move. This is, and these 500 and 300 are constant forces. But in case B, this external force is a variable force, is a function of time. So this is, so when you have constant force, mean you have constant acceleration. When you have variable force, then it means then you have variable acceleration. So first thing, let's draw the free body diagram for case A. We can represent the block as this dot or this particle of mass. So so here we have to the left we have the 300 Newton. Of course, the mass have a weight, so mass times gravity. The particle or the block is laying on a surface. That's the normal force. And then here we have the 500 Newton force vector that is not acting horizontally or vertically, and it's acting at an angle from the horizontal. So we can divide this into two components. Its vertical component and its horizontal component. And we can use the triangle relationship 3, 4, and 5 in here. So we can take here a quick look at this triangle, which is this. This is our theta, and this is a right triangle. And what's opposite to the right triangle is hypotenuse. What's adjacent is to the angle is the horizontal, and what's opposite is the vertical. So here we know that cosine theta is what? Is adjacent of our hypotenuse. Adjacent, as you can see, is 4. And the hypotenuse is 5. So if we want to find the horizontal component value, we will say 500 times cosine theta equal to 504 over 5. So now to find the angle theta, its actual value, what you can do is you can use the tangent relationship. Tangent is what? Tangent is opposite over adjacent. So what you can do is you can take the tan inverse of 3 over 4. If you use this angle that you found from the tan inverse and plug it in the cosine theta times 500, it will give you the same value as cosine times 4 over 5, which is 400 Newton. So this block, we're assuming that it will move to the right-hand side with a force in magnitude of 10 kilogram times acceleration, mass times acceleration. And as a convention, we always make sure that the positive x-axis in the same direction as the moving particle. So here we have our free body diagram. So we will take the sum of the forces in the x direction, and the movement is happening in the x direction, so it will be mass times acceleration. There is no movement happening in the y direction, and we're not adding the forces in the y direction because we don't have friction force to count for, because friction force is related to the normal force. All right. So the first external force is the 500 Newton horizontal component minus 300 going to the left, equal mass times acceleration. So we can replace the cosine theta with 4 over 5. Plug this into your calculator. It could be 400 minus 300 equal 10 acceleration. Then here what we're going to do is we will solve for acceleration. And the acceleration that we got is what? 10 meter per second squared. And since we are dealing here with what? We are dealing with constant acceleration, as you can see, 500, 300. And since our forces is constant, that tells us that our acceleration is constant. Then we can use these four equations, four constant acceleration equations. So let's take a look at the first equation. So what are we given? We are given 2 seconds. Initial velocity or velocity at 0 second is 0. Acceleration constant is 10. And here we want to know the velocity at 2 seconds or final velocity. So if you take a look at this first equation, we want to find the final velocity, okay? We have the initial 0, acceleration is 10, and time is 2. Good, so I think we can use this. But as a good practice, let's quickly go over the 3 remaining equations and see if we can use other one. Now, the second one, obviously, we cannot use it because it deals with displacement. Same thing as the third one, same thing as the fourth one. So we cannot use these. So the first one is a correct one to use. So we will plug in the found and given values into this expression right here. And then we can solve for the velocity at 2 seconds, which is 20 meter per second. Oh, this is a mistake in here, where there is no squared, just meter per second. Now the second case, B case, we will draw the free body diagram. The particle that have a mass, the mass will have a weight, mass times gravity. It's laying on the surface, so it will have a normal force. And here we have a variable force acting to the right, force as a function of time equal 20t. So that tells us that your mass is going to move to the right at a force of mass times acceleration 10a. And as a convention, the positive x direction will be on the same, the positive x direction will be the same direction as the moving particle. So the sum of the forces here in the x direction equal to mass times acceleration in the x direction. The only external force causing this particle to move is our variable force 20t acting to the right. And here mass is 10 kilogram. So from this point, we want to solve for acceleration in the x direction. So acceleration in the x direction as a function of time is 2t. So here we know that what? We know that acceleration is the change in velocity over time. We can use this relationship in this equation. So we can rewrite this expression as delta v in the x direction over delta t equal to 2t. We can take delta t, move it to the other side of the equation, become delta v in the x direction equal 2t delta t. Now we can take the integral on both sides of the equation. The integral in here will be from 0 to v, and the integral in here will be from 0 second to 2 seconds. So the antiderivative in here of dv in the x direction is velocity in the x direction, and the antiderivative of 2t is t squared, and between the limits of 0 to 2. So when we plug 2 squared minus 0 squared will give you 4. So that tells us the velocity in the x direction at 2 seconds is equal to 4 meter per second. Problem number 2. It tells us the 10 kilogram block is subjected to the force shown. In each case, determine its velocity at s equal displacement equal 8 meter if velocity equal 3 meter per second. So when the block is being displaced 8 meter, its velocity is 3 meter per second. Sorry, its velocity is 3 meter per second when the displacement is 0 meter. We are asked to find the velocity of the block when it is at a displacement of 8 meter. So here what's given to us is a mass m 10 kilogram, and we have final displacement of 8 meter and initial displacement of 0 meter, and an initial condition where the velocity as a function of displacement when the displacement is 0 is 3 meter per second. We're asked to find what is the velocity at a displacement of 8 meter or final velocity. So here we have 10 kilograms. These 240, 30 are constant applied forces on this block, causing the block, unbalanced forces causing the block to move. This is again a variable force acting on the block, causing the block to move. In this case, since we have constant forces, that means it's going to generate a constant acceleration. This one is a function as a force as a function of position, and because it's variable, our acceleration will be variable. So first we will sketch for case A, the force in the free body diagram. To the right, we have the 40 Newton. To the left, we have 30 Newton. The mass have a weight, mg, and we have a normal force and a downward force of 20 Newton. So the mass here, we assume it's going to move to the right. Mass times acceleration. Mass is 10 kilogram times acceleration, the x direction. And here our positive x direction in the same direction as the moving object. Now the sum of the forces in the x direction will equal to mass times acceleration in the x direction. Now again, we are not considering the forces in the y direction because there is no movement in the y direction. 2, because we don't have force of friction because there is a relationship between the force of friction and the vertical forces. So the external forces applied on the object is 40 minus 30 equal mass times acceleration. So here what we will do is our goal is to solve for the acceleration in the x direction, which will give us the acceleration in the x direction to be 1 meter per second squared. So in this, we know that these two forces, 40 and 30, we said are constant forces, so that means it's constant acceleration. So acceleration in the x direction is our constant acceleration. So that means we can use these equations. So what do we have? Initial is 0, final position is 8, initial velocity is 3 meter per second, and we want to find the final velocity or velocity at 8 meter. So if you take a look at the first one, we need to find the final. We have the initial, but we don't have time, so this one won't work. The second one, we have the final displacement, we have the initial, we have the initial in here. We don't have the time, so no, this one won't work. What about this one? We don't have time, so also this one won't work. I think this one will work. So we need to find the final. We have the initial, we have the constant acceleration, we have the displacement. So this one will work. So we will plug in the given and found values in this equation. And we'll plug this into our calculator. And we'll take the square root in here, so that will give us velocity at 8 meter will be 5 meter per second. The third problem tells us determine the initial acceleration of the 10 kilogram smooth collar. The spring has an unstretched length of 1 meter. So here we have a mass of a smooth collar of 10 kilogram, and we are told that the spring normal length, unstretched length, is 1 meter, and that's what we're talking about in here. So this is our collar, 10 kilogram collar, and this is our spring, and this spring have a spring stiffness of 10 Newton over meter, or we can say spring constant of 10 Newton over meter. So we said this is our collar, it's a 10 kilogram collar. And remember, here we're talking about smooth collar. So whenever in these problems you are told that you're dealing with a smooth mass or a smooth object or a smooth pulley, it means that you can disregard the friction force in these problems. So what are we asked to find in here? We are asked to find the initial acceleration. So you can imagine that you are holding this massive collar with your hand steady, and once you release it, the spring will move the collar to the left, because this is a stretched spring, and the spring have the tendency to go back to its normal or unstretched length. So it will move the collar to the left. So we want to know what is the initial acceleration in here. So first thing, we will draw the free body diagram of the collar right here. The collar will have a mass times gravity, will have a normal force, but we're not considering the vertical direction because there is, we're not considering any friction in here. This is the force due to the spring, and we will use this triangle, just like the triangle we have in here. This one will be a 90-degree triangle. So what we did in here is we just flipped this triangle. So that will be 3, 4, and 5. And so here the mass, or the collar mass, will move to the left at a force of mass times acceleration, 10 times a. And the positive x-axis is to the left because in the same direction as the moving object. So let's take a quick look at this force vector. So this force vector, we call it the force due to the spring, or for short F sub s. It have a vertical component and it have a horizontal component, and this is the angle theta. To find the horizontal component, since this is adjacent, we'll use cosine. So the force of the spring times cosine theta. And right here, this is our angle in here. So cosine is adjacent, which is 4, over hypotenuse, which is 5. So we can write the force of the spring 4 over 5. And the same thing for your vertical is force of the spring times sine theta. Sine theta is opposite, so here again, the opposite is 3 and hypotenuse is 5. All right, so the sum of the forces in the x direction going left is positive, equal mass times acceleration. So the only force that we have in here is the force in the horizontal force of the spring, which is force of the spring 4 over 5 mass times acceleration. Now, the force of the spring is, from Hooke's law, is the spring constant times the amount or the change in the spring original length, whether stretching it or compressing it. So in here, we know what is our K value. We need, our goal is to find the acceleration in the x direction. So to do that, we need to solve what is our x value. So from this right triangle, what we will do is we'll take the square root of 3, the square root of 4, using the Pythagorean theorem, and take the square root, and we will get a length of 5 meters. So this is the unstretched length. And we're told the stretched length is 1. So 5 minus 1 will give us what? 4. So the 4 meter will be the change in length of the spring. So we can plug in the given and found values in here. And our goal is to find the acceleration in the x direction, the initial acceleration. So our initial acceleration is 3.2 meter per second squared. Fourth problem. Here we're told to write the equations of motion in the x and y direction for the 10 kilogram block. And we're given a coefficient of friction, kinetic, 0.2, and we have an incline of 30 degrees. And we're asked to find equations in the x and y direction. So we will draw our free body diagram on this picture. So first thing, we draw the x-axis parallel to the surface, and the y-axis perpendicular to the surface. First thing, we have the force due to gravity, which is mass times gravity, and we can divide it into two components, the vertical and the horizontal. And this is the angle theta, which is the same as the 30 degree. So the horizontal here, this is the vertical, is adjacent to the angle, so it will be mg cosine theta. The horizontal in here is opposite, so it will be mg sine theta. And we're given the coefficient of friction, and it will oppose the direction of the moving direction, so it will be to the left. So that will be the force of the friction. Since we're dealing with force of the friction, we need to count for the normal friction. So here, the sum of the forces in the y direction is equal to 0, because there is no movement in the y direction. So that will be a normal force minus the other vertical is mg cosine theta equal to 0. We can solve for n to be mg cosine theta. So now, what is our y equation? It will be n minus, we plug in the values that we have in here. So it will be n minus 98.1 cosine 30 equal to 0. So this is your y equation. Now let's solve for our x equation, x direction equation. So the sum of the forces in the x direction going right is positive, mass times acceleration in the x direction. So the first one here is the mass times gravity sine theta and the force of the friction. So the mass times gravity sine theta and the force of the friction is what? Is mu k times n equal to mass times acceleration. And here we will replace n with the n that we found in here, mg cosine theta. And here we will plug in the given values and found their and use our calculator to find them. So for example, 10 times 9.81, it will be 98.1, and that will be our acceleration in the x direction. Thank you very much.